Let's get it started. Let's take a look at our next idea. We talked about direct variation yesterday, the other day, and we talked about how that's a direct connection one to another. So we talked very commonly, this idea is in terms of pay in your salary. You get paid $10 an hour. For every hour you work, you get paid that $10. You don't get paid $16 one hour and $4 the next hour for a total of the same 20. You get paid 10 and 10 and 10 and 10. That's direct variation. We have the opposite of that. We have inverse variation today, and that's what we're going to take a look at. By the end of the day, you can talk about how to find the constant of variation for inverse variation. You know how to find it for K for the other one. You can identify inverse variation equations. You can find missing values in that inverse relationship, and you can graph for an inverse variation. That's new for this one. Instead of just identifying graph, I know you could do that. This one is a slightly different looking graph. Okay, so let's take a look at this one. Inverse variation is a specific relationship in which the constant product, x times y, between two variables. That we have a constant product of when you multiply x and y, you get the same number every single time. And in the opposite of direct variation, where it's y divided by x. It's the complete inverse of the two. So the constant of variation is still referred to as k, okay? And the inverse variation equations are written like this: y equals k divided by x. So these are our three basic pieces. Some background information for what we need. So from here, let's start exploring, how do I find my constant? How do I find k? So again, let's do what we did yesterday. Let's solve for k. So if we know that y equals k divided by x, let's use our literal equations. How do we get rid of divided by x? And I know you guys all know you multiply both sides by x. So here, these two cancel. So k is equal to x times y. So this is even easier than than direct variation. I don't have to worry about doing y over x. I simply have to look at the two numbers and go and multiply them together. 1 times 20 is 20. 10 times 2 is 20. 4 times 5 is 20. This is an inverse variation relationship, okay? So I know my equation is y equals 20 over x, okay? And the same thing as I keep looking through this one. If it's inverse variation, I multiply them together, I get the same answer every single time, okay? So 1 times 28 is negative 28. 2 times negative 14 is negative 28. 28, not 24, and 4 times negative 7 is negative 28. So now, since I've got k, I've got y equals negative 28 over x. Okay. Take a minute and try number 4. All right, so you found this one. You found out that every single number was negative 27, so you found y equals negative 27 over x. And we can do the same thing whether we have ordered pairs or charts just like this one. We just check each one. Okay, 2 times negative 12, negative 12, negative 12, and then let's just check 5 times 2.4, negative 12. So we have that same y equals negative 12 over x. Okay, so it's pretty easy once you know that relationship, and you can always start with that base form of the equation and work your way backwards. Okay, how to find k for inverse variations. Okay, now that we know how to find k, and we've spent some time writing the inverse variation the equation for inverse variation, how can I identify inverse variation equations? Well, key to this is always set up as y equals k over x. Inverse, okay? So the y and the kx are on two different lines, okay? So if this is y equals kx, this is it right here. This one is a inverse variation, and 50 is k. But if I look at number 8, it's not inverse. This is actually a direct variation, so I don't want this one. This is a no, okay? Now, what happens if we have questions that are not exactly the same? What if it's not solved for y equals? Then the first step is to solve for y equals. So like on number 9, how do I get y by itself? I divide both sides by x. So I get y equals negative 14 over x. and this is direct variation, and so k is going to be negative 14. But if I look at number 10, to get rid of the divided by x, I've got to multiply by x. I get y equals negative 6x, and this is not direct variation once again. All right, take a moment and try these 4 problems, deciding whether they're inverse variation or something other than that. And if it is inverse variation, what is the constant of variation k? All right, so number 11, it is yes. When I simplify this by 2x, the two numbers will give me negative 20 over x. So that it is inverse variation, and k is equal to negative 20 in this case. Same here. If I look at this one, is this one inverse variation? No, because when I divide by 7, I get y equals 4x. This one's a little bit trickier. How do I get rid of my y? This one I'm going to use my proportion thinking. I'm going to come over here and go, okay, cross multiply x times y equals 72. How do I get rid of x? I'm going to divide by x. Y equals 72 over x. Then yes, this is yes, and k is 72. And then looking here again, same thing. How do I get rid of, I want y equals, right? So how do I get rid of times negative 4? I divide by negative 4. So I'm going to actually just come down here and put it as negative 4. This lets me go, okay, the answer is negative 5 over x equals y. So this is yes again, k is equal to negative 5. All right, now that I've talked about how to find k, how to use the equation form, how do I use inverse variation to find the missing value? Just like yesterday, you use an equality statement. You say that these two are exactly equal to each other. So, but it's even easier than yesterday because it's x times y is equal to x times y. So I'm going to say, if I do this, I'm picking the smaller fractions. I'm just telling you right now. I'm picking number 16 for the numbers. 6 times negative 10 is negative 60 is equal to 3y. Divide both sides by 3. Our missing term is negative 20. Okay? It's that easy. It's just the key to remembering when is direct and when is inverse. Okay, so if I'm doing, say, this problem right here, I've got 18 times 6, that's 108. So 9y equals negative 108. Divide both by 9. Y is equal to negative 12. Okay, so you can see how that works. It works the same whether I write it with numbers or letters. So if I work words here, it's the same here. That comma is that equal sign. So 9 times negative 6 is negative 54 is equal to 3x. Divide both sides by 3. I go, okay, goes into it negative 18 times equals x. Go ahead and try 20 and 22. So to start this one out, you got negative 48 is equal to negative 6x. And you found out when you divided both by negative 6, x was equal to 8. Here, 56 is equal to negative 4y. Divide both by negative 4. You get y was equal to 14, well, negative 14. All right, last thing I want to talk about is how to graph an inverse variation. We've graphed direct variation graphs, those linear graphs the time. This is a nonlinear graph, so it does not create a straight line. It creates actually a rational function. So it creates something that looks a little different. So what you're going to do when you create this, it gives me k, so I know y equals 16 divided by x. So I'm going to come over here and pick x's. I'm going to make myself a simple chart, say, okay, if x is, I don't want to use 1 because my graph's too small. So I'm going to say 2, 4, 8, and negative 2, negative 4, and negative 8. So if I plug in x here, 16 divided by 2 is 8. 16 divided by 4, 8 divided by it is 2. Next one. Negative 2, it's the same thing. 16 divided by negative 2 is negative 8, negative 4, and negative 2. So I'm going to graph these. Okay, where x is 2, it's 8. So this is 1, 2, 3, 4, 5, 6, 7, 8. So this is my first dot. Where it's 4 is 4 is 4 right here. and 8 over 2 up. So it's going to kind of look something like this. And I do the same thing on here. So I have -2, -8, -4, -4, -8, -2. That's the shape I'm going to get every time. I'm going to get this idea of these two curves that are honestly symmetrical through y equals -x. That idea. I'll do one more like this, and then I'll have you guys try one or two. Okay, so now I've got the same idea. Y equals 24x. Now, I hope you guys got the idea before. I use factors of 24 or factors of 16 to get my numbers to pick, and that's how I pick my x values, just to make it easier. So I'm going to say this one's going to be, we're going to do 4, we're going to do 6, and we're going to do 8. And we'll do the negative values, -4, -6, -8. So 6, 4, 3, -6, -4, -3. So I'm going to graph this. Okay, 4 to the right, 6 up. I'm going to graph the next one, 6 to the right, 4 up, 8 to the right, 3 up. And I'm going to go ahead and say I know this one's right here too. So I'll use -8 as well. I'll add -8 to my, 3 over here to my list, -3 and 3, so I can get my fourth point. Make it easier on me to graph it. And I have the same mirror on this side. I've got, that's 8, sorry, and this is -8. So I'm going to come over here. Okay, so -4 over, 6 down, -6 over, 4 down, and it puts me right here. I know I've got 3 over 8, and then I've got 8 over 3. So I've got the same idea. Sorry, you got to get my graph right. There we go. That same shape. All right, go ahead and try number 3. All right, so hopefully you guys thought that you're going to use, probably can't use 3, but you can use 4, you can use 6, and you can use 9, -4, -6, and -9. Those are the things that are within 10. So graph this one. So 4, that's 9, 6, 4, -9, -6, -4. So I'm going to graph it. Okay, 4 over, 9 up, 6 over, 6 up, and then 9 over, 4 up right here. So there's my graph. And the same thing here. I'm going to have that exact same pair over here. So -4, -9, 6, 6, 4, 9. Same shape. Okay? Now you're all set. If you have questions, feel free to reach out. I'd be happy to help. Have a great day.